Okay, good morning class. So today we're looking at paper 2, the second half I think. At this point we have covered up until question. Which question? Yes. Come in the buildings. Okay. So we reached question 4.3 yesterday. No? We must carry on from 4.3.2. That's correct? Okay. So in 4.3.2 the question says determine without the use of a protractor the sum of the interior angles of figure A. So how are we going to do that? What we do is we divide the shape up into triangles. How many triangles can fit in here? 3. And the interior angles of a triangle is 180. So 180 times 3 is 500. So the interior angles is 540 degrees. Not so? In 4.3.3, the size of the interior angle in figure B. Here we ask you for the sum of the interior angles, so I'm looking for all of those there. Whereas the size of an interior angle, which means to say, is one, or the size of one of these angles inside. Did you see that people? So how many triangles can fit in a 8-sided figure? 6. Not so? 1, 2, 3, 4, 5, 6. 6 triangles. How many triangles can fit in a 10-sided figure? 8. 12-sided figure? 10. So it's always 2 less. So here we have 8. So it's 8 minus 2, which is 6. So it's 1, 2, 3, 4, 5, 6. 6 sides. So it's going to be 6 times 180. 0 times 6 is 0. 6 times 8 is 48. Okay. It says 1080. Is that correct? So you say 1080 divided by how many angles are here? In the 8-sided figure, how many angles? 8. So 1080 divided by 8. 135 degrees. Does it make sense? You guys understand? Then they want to know in 4.3.4 the size of the reflex angle of A in figure of A. Reflex angle of A. So what are they asking there? They want to know the size of that angle. Okay? So firstly we need to know what this angle is then. So what we say? 540 divided by 5 is 108. Is that correct? What's 540 divided by 5? 108. What's the interior? 540. So I'm going to get the reflex angle. Say 360 minus 108. It's going to give you 262 degrees. Sorry? 252 degrees. Sorry. 252 degrees. Any confusion here? Any questions with regards to these shapes? No? Okay, in question 4.4, we are told that if triangle ADB, ADE, the small triangle here, is similar to triangle ABC. If that is the case, what do we know? The two triangles are similar, what do we know? Angles are equiangular, the angles are the same. What else do we know? The sides are in proportion. Not so? So if the angles are the same, the equiangular, and they are similar, the sides will be in proportion. Now very importantly here that the order is correct. So ADE is similar to triangle ABC. So the order is in the right order as well. The equal angles, like it is here, A is equal to A, D is equal to B, and C is equal to E, or E is equal to C. Can you see that? So the order is important though. Very, very important. Why is that important? Because once we conclude that triangle ADE is similar to triangle ABC, then we can conclude that AD over AB, AD over AB is equal to DE over BC equals AE over AC. We did this extensively last year, grade 9. Okay? There we go. Carry on. AD over AB is equal to DE over BC equals AE over AC. And the reason here is that triangle ADE is similar to triangle ABC. Okay. The question says calculate the value of X and Y in the similar triangles below. Given that AE is 3, this length is 3, EC is 6, so the whole length here of AE is 9, not so? AD is X, PD is X plus Y plus 1, so what is the length of AB? Remember we need the length of AB. What's the length of AB? 2x plus y plus 1. Not so? Then we are told that AC is perpendicular to BC. And DE is perpendicular. DE is here, perpendicular to AC, which means to say there's 90. Okay, do you guys understand? Alright, so let's just take this one quickly. So what is the length of AD? What's the length of AD? X over AB. Whole length, we spoke about that. What's the whole length? 2x plus y plus 1. DE? X plus 3y over half x minus a third y plus 2. AE is 3 over AC. So how are we going to calculate x and y here? There's two unknowns. So it's going to go into what? Two unknowns? Simultaneous equations, not so? So what I'm going to do is, I'm going to set that they equal to 3 over 9, not so? And we can set this here equal to 3 over 9. I could set it equal to this here, but then I'm going to go into something very, very complex. You understand? It wouldn't be wrong, but it's going to become something very big. Do you guys understand? So if x is equal to y, and y is equal to 2, what does that mean? X is equal to 2 and y is equal to 2. Not so? So what I'm doing here, I'm saying x over 2x plus y plus 1 is equal to 9 over 3. 3 over 9, sorry. So that's going to give you x over 2x plus y plus 1 equals 3 over 9. Which is the same as a third, not so? So what can I do here? Cross multiply. So what do I get? 3x equals 2x plus y plus 1. Okay? Take 2x over, becomes 3x minus 2x is x equals y plus 1. And this become equation. As we said, we're going into its simultaneous equation. On the other hand, what do we do? We also say now that 2x plus 3y over a half x minus a third y plus 2 is also equal to 3 over 9. But what is 3 over 9 equal to? A third. So I replace that with a third. So, okay? Cross multiply again. So 2x plus 3y times 3 is going to give us 6x plus 3y. No, 9y. Equals a half x minus a third y plus 2. Now what? What do I do now? Get rid of the fraction. How do I get rid of the fraction? Multiplied by its LCM, which is 6. Okay? 6x times 6 is 36x. 6 times 9, 54y. A half times 6 is 3x. Negative 3 times 6, negative 2y. 6 times 2 is 12. Okay? So what do I do now? Bring everything to one side, not so? So it's going to be 36x minus 3x plus 54y plus 2y equals 12. I could have brought x's one side and numbers the other side, doesn't matter. I'm just simplifying it a bit so that I can substitute equation 1 into this equation. That's what I'm doing, okay? So that's going to give you 33x plus 56y equals 12. And this is equation 2. So what do I do now? To substitute equation 1 into equation 2. So wherever I see an x, I put y plus 1. It's going to be 33 into y plus 1 plus 56. Y equals 12. Did I make a mistake? Not yet. Okay? So it's going to give you 33y plus 33 plus 56y equals 12. Now what? Take 33 over. So what is 33y plus 56y? 99y. 89y. Okay, what is 12 minus 33? Negative. So y is equal to Negative 21 over 89. No, it's in fraction form. Same. Negative 21 over 89. Check if that's correct. It's correct? Okay. Now I'm feeling better. Now what? Substitute it back into equation 1. Not so? So we have equation 1. We're going to substitute y is equal to negative 21 over 89 into equation 1. Not so? Okay. So x is equal to negative 21 over 89 plus 1. Okay, this is an answer of 68 over 89. Okay? You guys understand? Any confusion? Right. You guys can watch the video again, eh? Right. You guys have access to the videos. If you don't have access, you just let me know and I'll send you the link. Okay? Alright, now we're on question 5. Question 5, make it a bit smaller. Given the diagram below, we are told that QU is equal to TS, as is marked equal. The question says, identify with reason quadrilateral PQRS. So it's P, Q, RS. What type of shape is PQRS? What? What's a quadrilateral firstly? Four-sided figure. Not so four, it's a polygon. Eh? Is this regular or irregular? Irregular. Why? All the angles is not the same. Or all the sides are not the same. Okay? So, what type of shape is this? Parallelogram. Why? Because two pairs of opposite sides. You all okay with that? Right, let's look at the next question. Delete. Okay, so if this is now a parallelogram and we proved it's a parallelogram, all the parallelogram properties is applicable here, which is what? Opposite sides are also equal. No? Opposite angles are equal. And one more that is not applicable here is what? The diagonals bisect each other, they cut each other in half. You all okay with that? Okay. So prove that triangle PQU is congruent with triangle RST. When we prove similarity or congruence, we start with the same. We say in triangle PQU and triangle RST. Now people, this order here, most of the time is the right order. The reason why we give the order in the right form, because if you don't manage to prove 5.2, you can use that information in the rest of the question. That is why the order, we give it in the right order. You all okay with that? Right. So what can we say about the two triangles? TS is equal to QU. Why? Given. What What else can we say? Angle Q is equal to SY. Opposite angles in parallelogram are equal. Okay, equal. One more. PQ is equal to RSY. Opposite sides equal in parallelogram. You all okay with that? Very important, people, is that you can't say properties of parallelogram. Okay, it's not suffice, it's not enough to get the mark. You're going to lose the mark. Okay? You must name the property you are referring to. Okay? So this is easy enough to prove congruency. There are 4 cases of congruency. Okay, what are the 4 cases? Side, side, side. Side, angle, side. And this is the one we're using here. There's a condition for that one. What's the condition for side, angle, side? Must be the included angle, yes. Which is you have 2 lengths referring to an included angle, which we are using here. Not so. And the other one? RH is right hand hypotenuse side. And our favorite? Angle, angle, side. Not so. Right. So, we can conclude therefore, triangle PQU is congruent to triangle RST. Why? Side angle side. So what does that mean? If the 2 triangles are congruent, all the corresponding angles and all the corresponding sides are equal. Which now means that angle P is equal to angle R. Angle Q is equal to angle S. We knew that already. And angle T is equal to angle U of those triangles. Can you see that? What else do we know? We know that PQ is equal to RH, but we knew that one already. Not so. We also now know that QU, we knew that also already. And PU is equal to RT, or TR. Can you see that, people? Okay. Let's take it black off. I'm taking it off so that the diagram is not overpopulated, okay? Also in the exam, don't scratch too much on the diagram. But importantly, what you found on the diagram, you draw it in on your answer book and not in the question on the question paper. Because when we get your answer book, when we mark, then we can follow your logic. Okay, sometimes you'll get a mark on your diagram. Okay, if you haven't represented it properly. Okay? It also depends if that is enough for us to give you the mark. Okay. So at the end of the day, we just want to give you marks, but you guys don't want it. Right, so we've done 5.2. Let's look at question 5.3. It says, hence, prove PU is equal, hence, complete. PU, let's go to PU. PU is equal to TR. Why? Huh? Triangle PQU is congruent to triangle RST. It's coming from here. Not so? Do that again behind the calculator. Move this over. Right? You all okay with that? And note again, I'm putting it on the diagram, what we have stated. I keep it on. Why? So that from one glance, I can see what we have. You guys okay with that? So what I'm going to do is take this off. Just to keep the diagram in focus. So we are told that if QUP is 70 degrees and TRS is 30 degrees and angle S is 80 degrees. Calculate UPT. Angle UPT. So in other words, that's the angle I want to calculate. So that's the easy one. What is the angle of UPT? The angle. What's the size of this angle? 70 degrees. Why? It's alternate angles. With PS being parallel to QR. Or UR, or U, or RU, or RQ. The same. You all okay with that? So that's 75 degrees. Or 70. 70. Okay. Then they want you to work out the size of angle TRU. T or U. This angle. How are you going to calculate that angle? It's alternate to this angle here, not so. So we must first work out that angle. How are we going to work out STR? Interior angles of triangle, TSR. But it's another way of doing it. Sorry? Corresponding. Yes, it's corresponding. But we have to first prove that these lines are parallel. So not corresponding at this stage. Yes? Opposite sides. Opposite angles. This here. Okay, just hang on. Under what condition would that angle be equal to that angle? Just hang on. I want to first disprove or explain to them why you can't say that. Is that okay, people? Give everybody a chance. Alright? So my question is, why can we say that is not equal? It is not what? Sorry? Here we go. He's not given a parallelogram and we haven't proved it's a parallelogram. You guys understand? Although that one is parallel, this has to be noted parallel as well. Then it will be a parallelogram. Then opposite angles are equal. You see, in geometry you can't just assume. Okay? And that is why we can't go with that fact. Right. The next question, anybody? Yes, on the side?
No, sir, it's fine.
To go with. What were you thinking?
I was going to say, can't you prove that it's a parallelogram?
You can prove it's a parallelogram, but to prove something is a parallelogram is minimal 3 marks. Okay. At this point it will be 3 marks. Why? Because we must work out, and we must first prove that lines are parallel. The other set of lines are parallel. Okay. It's not going to be 2 marks. Yes, Bansi? Here we go. You all see that? Co-interior angles there. Did you see the U there? You all see that, people? The U, co-interior. So, it's going to be 80 degrees plus 30 degrees plus that angle in question, which is TRU, which is equal to 180. Why? It's co-interior angles with PS being parallel to QR. So TRU is equal to 180 minus 210. No. 110. Or 80 minus 30, which is 70 degrees. So people, if the exam, if you were in the exam and you got 70 degrees here and your answer was, and your reason was opposite angles of a parallelogram is equal, how many of the 2 marks you think you're going to get? Nothing. The reason for that is because it's what we call a breakdown. You are assuming something that is not true or haven't been proven yet at this point. You guys understand? So you will be penalized for it. Yes?
So, here then, interior angles of TSR and
TSR, we just check what you're talking about. T is R, yes? You would have gotten that angle.
Yes.
And then alternate them. Yes? That was one of the first suggestions we got. But those steps are minimal 3 marks, what you're talking about. But since it's 2 marks, we look for the quickest way to bag those marks. Okay? Any confusion here? No? Let's look at the last question in the paper. So prove that T, okay, I'm going to take this off here. Ne? So whatever I got calculated thus far is on the diagram. Okay? Okay, you can't erase the highlight. Now I've done something else as well. Right, let's go with another color. In 5.5, must prove that PUT is congruent to triangle RTU. RTU, that triangle. Now, so, how do we start off congruency or similarity? We say in triangle PUT and triangle RTU. Do not say, people, they are congruent at that point. You're going to lose them all. Okay? Because in a prove that or in a show that question, you don't write the answer on top. You can't use the fact that the 2 triangles, we're going to prove it's similar or congruent in our proof. Make sense? So, never write whatever the proof, unless you say RTP, required to prove, that next to it is fine. But just refrain from it, stay away from it rather. Okay? Especially when you guys are scratching over your geometry and coloring in and all of those things. Okay? Make it clear in what you are doing. Okay? Don't let the examiner look for where's your answers and all of those things. Okay? So what do we say first? What can we say about those 2 triangles? What can we say first? Sorry? Sorry? P? Angle P is equal to angle R. You all agree with that? Is it safe for us to just say angle P? No, there's 1, 2, 3 angles there. Even though in this setting you won't lose a mark, because we have stated on top which 2 triangles you are referring to. So saying P and saying R, it's okay. You won't be penalized. But rather play it safe. So we're saying UPT is equal to TRU, which is equal to 70 degrees. Where do we get that from? It was proven to us. Not so? So, what else can we say? Angle U, this one here. Talking about that angle? You have your cam, you're hearing the common side. This here. TU, yes? TU is a common side, yes. Remember, for congruency, we must have at least one side. There's your side, yes? TR? Just hang on. T? UR. Yes, this angle? PTU. Do you all agree with that? Yes, it's alternate angle Z. The Z is being formed. Okay, so P TU is equal to TUR. Why is that equal? Alternate angles. With PT is parallel to UR. Is this enough to conclude congruency? Yes. So I can say therefore, triangle PUT is congruent to triangle. Congruent. This is similar. Congruent to triangle RTU. Why? Angle, angle, side. Our favorite, no? Angle, angle, side. Okay. Otherwise, we could have said, look at this. Could we have said, instead of using this, could I have said that TR is equal to PU? That was proven already, not so? But let's see what we have. We have a side, and we have that side. If we have two sides and an angle, what is the condition? It has to be the included angle. Side, angle, side. Have we proven that that angle there is equal to that angle there? No. So could I have used this? No. Why? Because it's not enough to prove congruency. Does it make sense? It must be the included angle. Alright? Any confusion here, people? Alright. So that basically brings us to the end of this set of papers. Okay? So what is the next paper we're working on? Sorry? November 2019. The San Susi paper. Alright, so we'll go straight in that paper now.